Imagine for a moment being able to peer beneath our feet, just as clearly as we see the world around us.
Right. No jackhammers, no digging.
Exactly.
Yeah,
No disruption, just a kind of, underground X-ray vision.
that's a good way to put it.
Today on the Deep Dive, we're plunging into this increasingly real world of non-invasive underground mapping. We'll explore the incredible possibilities. What happens when we can really see what's buried?
And how it's moving from like science fiction to actual application pretty fast.
So we've looked at a bunch of different sources for this.
Yeah, we've dug into the underground mapping industry itself, the technologies involved, obviously, and some of the key companies making it happen.
Our mission today is really to give you a clear picture of this field, why it matters, some of the surprising innovations, without getting too lost in the weeds.
Exactly. Keep it engaging, show you what's changing.
And we're going to zoom in on three companies in particular. First is Exodigo. They seem to be really leading the charge with this AI-powered multi-sensor approach.
Right. Fusing lots of data together. We'll also touch on cobalt metals and atomionics.
Yeah, they're doing some really advanced stuff, more focused on finding resources. Okay, so let's dive in. Why is seeing underground actually such a big deal?
Well, it's fundamental to so much of our modern world, isn't it? Think about cities. Underneath, you've got this incredibly dense tangle of utilities,
Water, gas, power lines, fiber optic.
all crammed together. And as cities grow, it just gets more complex. Managing that, maintaining it, it's a huge challenge.
So it's not just about putting new stuff in, it's about managing what's already there.
Absolutely. And knowing accurately what's there. Inaccurate or old records are a massive problem. It's like trying to navigate blindfolded sometimes.
And the consequences of getting it wrong. I mean, hitting a gas line, that's terrifying.
It's incredibly dangerous and incredibly expensive, too. Damage prevention is a huge industry in itself.
We saw a source mentioning Uzik in the U.S.
Yeah.
doing tens of millions of locates every year.
Yeah, tens of millions. Just marking existing lines before digging starts. It shows the scale. And companies like GPRS really emphasize the safety aspect, beyond just time and money savings.
Okay, so avoiding disaster is key. What other sectors really depend on this?
Oh, lots. Utilities, obviously. But transportation is huge, too. Think subways, tunnels, even road building. You have to know what you're digging into.
Makes sense. Prevents delays, structural issues.
And construction in general. Knowing where utilities are avoids those costly strikes. Companies involved in major projects stress how vital this upfront knowledge is for planning and just, well, efficiency.
And you mentioned resource exploration earlier, too. That's another big application.
Definitely. Finding those critical minerals we need for batteries, for the energy transition, that's where companies like Cobalt and Atomionics come in, using advanced mapping to find things like lithium, cobalt, copper.
Okay, so the need is clear. It solves problems across the board. What are the main hurdles with the old ways of doing things that make these non-invasive methods so appealing?
Well, like we said, those inaccurate or just plain missing records are a big one. Things change underground, pipes get replaced, new lines go in, and the maps don't always keep up.
Especially in older cities, I imagine.
Exactly. Plus, the sheer density now, it's just getting more crowded down there, and then there's the inherent risk and cost of accidentally hitting something. Every time you dig, there's a chance.
Right. So let's talk about the how. How is this what-if becoming reality, these non-invasive technologies?
Yeah.
How do they compare to, say, just digging a hole?
So you have invasive methods first. That's things like potholing or vacuum excavation.
Basically digging small test holes.
Yeah, or larger test pits, soil boring, even sticking cameras down pipes. They give you direct information right there. But they're slow, disruptive, and only tell you about one specific spot.
And you had to disturb the ground.
You do. Non-invasive methods are the opposite. They let you survey much larger areas much faster and, crucially, without digging anything up.
Okay, so what's in the non-invasive toolkit? Ground-penetrating radar? GPR? Feels like the one people might have heard of.
GPR is definitely a cornerstone. It works by sending short pulses of radio waves into the ground.
Like radar for the Earth.
Pretty much. When those waves hit something different, a pipe, a rock, a change in soil layer, some energy bounces back. Analyzing those reflections lets you build a picture.
And it can find different materials.
Yeah, that's a big plus. It can detect metallic and non-metallic objects like plastic pipes. Companies like GSSI Geophysical are big in GPR, but
There's always a but.
yeah, soil conditions matter a lot. Really wet soil or heavy clay can limit how deep the radar waves penetrate or make the image fuzzy.
Okay. What about those tools utility workers carry, the EM locators?
Electromagnetic locators, they work differently. You usually induce an electrical current onto a metal pipe or cable.
You need to connect to it,
Hmm.
or just get close.
Sometimes you connect, sometimes you can induce the current passively. This current creates a magnetic field around the conductor, and the locator wand detects that field, letting you trace the line. Vivax Metrotech, radio detection, make these. Very effective for metal.
But only metal.
Primarily, yeah. That's the main limitation. They struggle with things like PVC or fiber optic cables unless there's a tracer wire buried with them.
So GPR finds more types of stuff, but soil can be an issue. EM is great for metal, but misses plastic. Seems like you need both, maybe?
That's often the case. And there are other tools too. Acoustic sensors can literally listen for leaks in pipes.
Listening underground. Cool.
LiDAR, which you usually think of for mapping above ground, is being combined with GPR and GIS systems to link surface features to what's below.
Ah, connecting the dots.
Magnetometers are good for finding old iron pipes or tanks, but again, only ferrous metals. Even satellite imagery, believe it or not.
Satellites, how do they see underground?
They don't directly, but companies like Forum Analytics use AI to analyze surface features, terrain, vegetation patterns, things that might hint at buried infrastructure over large areas.
However, any others?
Thermography can sometimes spot heat signatures from leaks or active cables near the surface. But the real power, as you hinted, comes from combining these.
Multi-sensor fusion.
Exactly. Using several technologies together and integrating all that data gives you a much more complete, much more reliable picture than any single one alone. Which brings us neatly to Exodigo.
Right, Exodigo. They're all about this fusion approach, aren't they? What makes them stand out?
Their whole system is built around AI-powered multi-sensor fusion. It's not just using multiple sensors, it's how they use them and process the data. They have this really systematic scanning method.
How's it different?
Instead of just trying to trace a line they suspect is there, they scan the entire area of interest very densely, like mowing a lawn, but with sensors, captures way more data points.
Ah, so less chance of missing something off to the side.
Precisely. And they use a wide array of sensors, multi-frequency EM, magnetic gradiometers, GPR across different frequencies, a whole suite designed to pick up basically anything, whatever it's made of.
So metal, plastic, concrete. Doesn't matter.
That's the goal. Detect everything. But the sensors are only half the story. The AI platform is where the magic happens.
Okay, tell me about the AI.
All that raw data gets uploaded to the cloud. Then their algorithms run these incredibly complex physics simulations.
Simulations, like virtual digging.
Kind of. They test millions of possible underground layouts against the sensor data to figure out what configuration best explains the signals they detected.
Wow, that sounds computationally intensive.
It is, and the AI has been trained on huge data sets from past projects, so it learns and gets better. It automates a huge amount of the analysis, reducing human error and speeding things up dramatically.
Is it fully automated?
Mostly, but they do have what they call a human in the loop for tricky edge cases. An expert reviews the complex stuff.
So you get this incredibly detailed map without digging a single hole.
That's the idea. Non-intrusive. And they claim very high positional accuracy, like down to inches or centimeters. They also fuse it with above-ground imagery, so you get a really clear combined view.
What about their results? Any claims on how much better it is?
Yeah, they claim they locate significantly more lines, maybe 20 to 30% more than traditional methods. And maybe even more impressively, they say they can reduce the need for preliminary or exploratory digging by up to 90%.
90% less digging. That's huge for project timelines and costs.
It could be transformative, yeah. Those are big numbers.
Are companies buying into it? Are we seeing it used?
Definitely. They've got partnerships with major players, utilities like National Grid, GRDF in France, big construction firms like VinCI. That shows real industry adoption.
And they've raised significant funding too, right?
Yes, $118 million mentioned in the sources. That level of investment signals strong confidence in their technology and market potential.
Okay, so Ixigo is really focused on that comprehensive AI-driven infrastructure mapping. Let's shift gears slightly to cobalt metals and atomionics. Resource exploration. How are they tackling seeing underground?
Cobalt Metals has this really interesting vision. They call it Google Maps for the Earth's crust.
Oh, I like that.
Their focus is specifically on finding battery metals, cobalt, lithium, nickel, copper, things critical for, EVs and renewable energy storage.
So how do they map for metals?
It's very data-driven. They use AI and machine learning to crunch just vast amounts of geological data, historical drilling records, satellite data, magnetic surveys, gravity data, geochemistry, everything they can get their hands on.
Looking for patterns the human eye might miss.
Exactly. They have their own data platform, TerraShed, and an AI called Machine Prospector. The AI sifts through everything to identify areas with the highest probability of containing these specific mineral deposits.
So they target exploration much more precisely. Less guesswork, less speculative drilling.
That's the aim, and they've had success. Our sources mention a significant historic copper discovery in Zambia attributed to their AI approach. They're even exploring things like muon tomography.
Muon tomography, like using cosmic rays.
Yeah, using naturally occurring muons to get density information about rock formations deep underground, very cutting-edge stuff for mineral exploration.
Fascinating. Okay, and atomionics. Quantum sensors, you said?
Yep.
That sounds even more sci-fi.
It really is pushing the boundaries. Atomionics uses quantum technology, specifically cold atom interferometry, to build incredibly sensitive gravimeters.
Gravimeters, measuring gravity.
Exactly. Tiny, tiny variations in the Earth's gravitational pull. Denser materials underground, like ore bodies, exert a slightly stronger gravitational force.
So you can detect dense stuff by measuring gravity very, very precisely.
That's the principle. Their main device, Gravios, is described as the first commercial absolute quantum gravimeter that's mobile. It gives very stable, drift-free measurements.
And what do they do with that gravity data?
It feeds into their AI platform, which they call Oreo. The AI uses the gravity map along with other geological data to build 3D models of the subsurface and pinpoint potential resource locations. They call it a virtual drill.
A virtual drill. I like that too. And this is non-invasive as well.
Completely. You just move the sensor across the area. It's potentially much faster and cheaper than traditional exploration methods that rely heavily on drilling campaigns.
What's their big picture goal?
Pretty ambitious. They want to create a global map of Earth's crust, identifying resources. They're already doing pilot projects, like with Bridgeport Energy in Australia.
Wow. From mapping city pipes to mapping the planet's resources, it's incredible the range of applications. So, looking at the whole market for this underground vision, how big is it? Is it growing?
Oh, it's significant and definitely growing fast. All those factors we talked about, infrastructure needs, urbanization, safety concerns, smart cities, they're all pushing demand. The total addressable market is easily in the billions globally and expanding.
What are the main drivers pushing that growth right now?
Infrastructure development is a huge one globally. Managing aging infrastructure in developed countries. Urbanization means more density, more complexity underground. Safety regulations getting stricter. Even things like the 5G rollout require precise underground work. Construction volume remains high. It's really a convergence of needs.
And AI seems to be woven through so much of this progress. How central is it going forward?
It's becoming absolutely central, I think. Processing the sheer volume of data from these sensors, AI is essential. Detecting subtle anomalies, AI again. Predicting potential problems, building automated maps, fusing data from different sources like GPR, EM, LiDAR. AI is the key enabler.
You mentioned Exodigo, but other companies are using AI too.
Oh yes, 4M Analytics with satellite data, Preserve, Memo Detect, ULC technologies. Many players are leveraging AI for smarter analysis and interpretation. It's moving beyond just collecting data to actually understanding it much more deeply.
So looking ahead, what other advancements are on the horizon? What's next for seeing underground?
Continued improvement in the core technologies, GPR getting better depth, better resolution, smarter AI interpretation, tighter integration of LiDAR for that surface-subsurface link.
More multi-sensor platforms.
Definitely. Probably becoming more compact, more affordable. Quantum sensing like atomionics is really exciting, though likely still early days for widespread use beyond high-value exploration.
What about real-time data?
Yeah, IoT sensors for ongoing monitoring of underground conditions, think pipeline integrity or soil stability. Better integration with GIS and BIM software for managing the data. Augmented reality is interesting too.
AR, how would that work?
Imagine wearing AR glasses on a construction site and literally seeing the pipes and cables mapped out beneath your feet, superimposed on your view.
That would be incredible.
Cloud platforms for managing the data will become standard. Drones for faster surveying combined with ground sensors, mobile mapping systems getting more sophisticated. It's all moving towards faster, more accurate, more integrated data.
It really does feel like we're heading towards a future where the underground isn't such a mystery anymore.
That's the goal, isn't it? To make the subsurface transparent. That leads to safer work, more efficient projects, better resource management, just a smarter way of interacting with the hitty half of our infrastructure.
So summing it all up, the takeaway really is that this ability to non-invasively see underground, it's not science fiction anymore.
Not at all. Technologies like Exadegos combining multiple sensors with powerful AI and the specialized approaches of cobalt metals and atomionics, they are fundamentally changing the game.
And for you, listening, this means potentially fewer road closures, safer construction sites in your neighborhood, more reliable utilities, and smarter use of resources.
Yeah, the aha moment is realizing how fast this is moving and the ripple effect it will have. It touches almost everything related to infrastructure and how we build and maintain our world.
Okay, final thought then. As these technologies get even better, even more precise, even more widespread,
Yeah.
what new possibilities open up? If we truly have a real-time, comprehensive map of everything underground, what new questions can we finally ask about our planet? What can we finally answer?